Welcome back to Tech Talk, where we go into the latest developments in the world of AI and ML, and I'm your host, Nomuka. Today, we're discussing the new results announced by MLCommons from their MLPerf benchmark suites. Now, we all know how difficult it can be to compare different systems, especially for complex and emerging technologies in the field, in fields like AI and ML. So I thought it'd be great to have some experts with us to shed some light on this topic. And just to give a little background information about MLCommons, and as stated by themselves, the MLPerf Training benchmark suite comprises full system tests that stress machine learning models, software, and hardware for a broad range of different applications. And what's really great is that it's open source and peer-reviewed. So it provides a pretty, level playing field to compare different systems across the entire industry. So I thought it'd be a good topic for us. And I'm here today with some of the engineers from Dell behind the technology submitted here and other platforms to get their insights and answers to questions that aren't included in things like the announcement. So it's great to have you guys on here today, Fabricio and Rakshith. To start us off, can you give us a little introduction about yourself and your past experience with Fabricio?
Sure, Nomuka. My name is Fabricio Bronzatti. I'm from Brazil. I worked at Dell since 2009. So I've been working on the infrastructure solution engineering for specifically with AI solutions for about 1 year. And I've been participating on the development of AI solutions and also helping with the benchmarks like MLPerf.
Yes, I know you worked in similar submissions, so it's really great to have you here to be able to ask educated questions from Rakshith. And Rakshith, if you could give an introduction.
Absolutely. Thank you for having me. I'm Rakshith Vasudev. I've been with Dell since 2019. A lot of the focus has been on performance benchmarking and things of that nature. So I work at the Austin office and the HPC AI Innovation Lab. As you may know, HPC AI Innovation Lab is a 13,000 square foot data center, houses a supercomputer, and a lot of cool stuff like, state-of-the-art GPUs, CPUs, a lot of storage and compute for all kinds of great work our customers are doing and helping them. So the focus for me has been, how can we improve systems performance? How can we enable profiling to understand their behavior? And what does it take to extract a little bit of extra performance out of the systems that are particularly in the training stage or in the inference stage, which we'll be discussing. But that's a quick intro for me. Thanks.
Thank you for that introduction. And, both your expertise is really needed here. And just to get started with the whole topic, when it comes to the MLPerf Training v3.1 benchmark suite, how does it actually measure the performance of training machine learning models for things like generative AI, other use cases? What are the key parameters and metrics that are used in this? If you could give, introduction to the audience and just a background on those topics.
Sure. MLCommons is the body that runs MLPerf benchmark. So this was founded by large tech companies, research institutes, and academia, folks from academia as well. So the focus for MLCommons, when it started, was mostly benchmarking, but now it is actually growing to do other areas of AI work as well. So some of the work they do is exploring how we can make AI better for everybody. So benchmarking comes under the idea to measure systems. So as Peter Drucker said, whatever gets measured gets improved. And MLCommons started as a platform, a benchmarking platform to enable fair assessment to the best of possible, real model workloads. So fair assessment could be, how could we compare two different systems? Well, it's a really challenging problem if you think about it. So what happens, how do you compare two different systems when, for example, a lot of the stuff is siloed? Some people use a different version of the software stack. Some people use different hardware stack. There was not a platform that could do what could be an apples to apples comparison. So like to like comparison was the intent of MLCommons, and the expansion of it has been very interesting to see. So MLCommons has had several rounds of MLPerf training submissions and inference submissions, and Dell has been an active participant to that. So we've made quite a bit amount of submissions for training. This is our 8th submission with MLPerf Training 3.1. So we've had a lot of interesting results. To fairly quickly explain MLCommons benchmarking mechanism, they have two major divisions. It's called closed division and open division. Closed division intends to really do exactly like-to-like comparison. So what that means is they have a reference implementation. This reference implementation is what guides the submitters to make a reference from and implement it to their optimized versions. So the criteria for reference implementations are very detailed, and it's actually outlined in the MLCommons training rules. We can look at it in their GitHub. However, from a bigger picture, the idea is, all the submitters are doing the same math, are using the same data set, are using the same approaches for training the model. And a lot of these are very detailed specifically for every model that is trained. So if we specifically talk about the models in the benchmark, we have image classification model, object detection, two types of object detection models like the lightweight and heavyweight. We have medical image segmentation model. We have text to speech model, the RNNTs. We have the other model, which is to do GPT-3-like language modeling tasks with NLP. That was recently introduced in version 3.0, I believe. And then we also have a text to image model. That's the stable diffusion model. So you may ask, where are these benchmarks picked up from? What is the motivation to pick these benchmarks? The motivation is that it's actually driven by a lot of the users. They conduct interesting surveys. They just sense where majority of the customers are, what type of workloads majority of the customers are using the compute for, and then they try to somewhat mimic the most relevant use case scenarios for the customer's setting. So that's a very, I guess, broad overview of MLPerf training benchmarking.
That's a great introduction. And any thoughts on that, Fabricio? To add or about your experience with MLCommons or MLPerf?
Sure, I participated on two MLPerf inferencing benchmarks, but I didn't yet participate on the training. So I have some questions to you, Rakshith, from engineer to engineer. The first one was about the specification. We are basically talking nowadays about server benchmarking. And how does the specification of the system impact the training results on the benchmark?
Yeah, that's a great question. So like I discussed, Dell has been making quite a bit of submissions. So we've made submissions starting from the version 0.7 all the way till now, and we hope to continue to make those submissions. So the submissions included several hardware components. You have state-of-the-art GPUs. We've made submissions from V100 all the way till H100. You've seen the whole cascade of wonderful high compute GPUs that have made a lot of the great work possible. So our goal in these submissions is to not just get the best results, but also to cater to a large set of audience. The effectiveness of this is that customers can look at a specific benchmark for their use case. Customers can look at a specific GPU for their use case. Customers can look at specific system for their use case. So essentially, there's this a big set of variables that the customers could be interested in, and we hope to fill the whole matrix of, although it's a very grandeur of a hope, we still try to provide a lot of the numbers and results so that the customers are able to make a lot of sense from it. So the effectiveness is in multi-fold. So when somebody actually looks at a result, they can see that the results comprises of the system specifications. Actually, if we go to MLCommons.org website, we are able to look at all the results. They're publicly available. And when somebody looks at a specific result, every result is tied to an ID. And then if we go through that entirety of the row, you'll be able to see the system. And when you click on the system details, there is a .json file that opens up. which describes all the hardware components and the software components. And you can see that the hardware components and software components have been continuously evolving. The expansion of these components are what enables customers to make informed decisions of. So does that help a bit, Fabricio? To just give you a quick overview of the submissions we have made.
Sure. That's great, Rakshith, and it's good for our customers to know that they can really go on their MLCommons.org and see exactly what was the processor, the memory, the version of the CUDA in case of the GPU tested. So it's very nice to make sure that customer has access to that information.
Absolutely, and the interesting thing is all these numbers are comparable, and that's why MLCommons has become the default benchmarking platform. So if you look at our results from one system to another system, the numbers are actually a fair representation of what the customers could expect in their data center, in their deployment environments. So when they look at these numbers, it's comparable. It's not just comparable across our systems, it's also comparable across other submitters. So you have submitters, from various focus groups. Like, for example, there are submitters who are just OEMs. You have submitters who are accelerator submitters who have made the likes of NVIDIA and things and other accelerators. Intel Habana is a submitter as well, and we also have cloud vendors as well. So there's a plethora of results that the customers can look at and compare. So they're able to get the most value to make reasonably well-informed decisions.
Yes, and I like that beyond, being comparable with, as you said, the plethora of information they have, it's also replicatable. The customer can also get it and be able to get the same results for themselves. I think a lot of times, you see the results, and when customers do it themselves, they might not know the exact system, specifications that will get that result. So it's really good to have all that information out there. And then Fabricio, any more questions for Rakshith about?
Exactly. Before we get there, one more point to that is, like you said, it's one of the major goals of MLCommons is not just to publish numbers, but also to enforce reproducibility. So that's a great point you brought up, which is customers can actually look at the code. If you go to MLCommons.org, there's a path to the implementation. So you'll be able to see all the optimizations that were made, that these optimizations could be carried home to their data centers for customers. So whatever workload they are running, they're able to effectively utilize these optimizations to improve their performance as well. So in a lot of cases, adding new hardware helps without, we've seen time and again, if you upgrade from a hardware an accelerator that came prior versions and you upgrade to a later version of the accelerator, you'll certainly see a jump in performance. But also, without doing that upgrade, it is possible that customers can look at the implementations that are optimized, and these are vendor optimized implementations. So you can expect that if you somehow are able to bring that to your environment, similar kind of optimizations, you are able to extract more performance in your data center results. And that's a good thing to have, even without having to upgrade an accelerator or the system. Although we are more than happy to assist you with specifically how we can, accelerate, what kind of upgrades you could make to your accelerators, what kind of upgrades you could make to your data center systems. And, those are some topics, maybe if time permits, we can discuss, but certainly very exciting for customers and users and partners, everyone, to be able to reproduce and improve the system performance.
Yes, and have, data that's actually actionable that you can act on without, that's not just nice to have, the system, et cetera. As you said, you can actually make improvements based on it. So that's a great points. And then, going back to Fabricio, any more questions for Rakshith or input?
Rakshith is very interested, and as you mentioned, the inference benchmark, I remember that we have the power benchmark that measures how much power the machine consumed during the benchmark. So it's very interesting to understand how these benchmarks can help the customer from the beginning of their experience on writing their RFP and identify what models or what type of workload they will test and what are the minimum performance that the system needs to provide, passing through the capability of measuring what the data center or even the edge when we thinking in deploying the model, the inference model at the edge, how much power this machine will use, or even if the customer is studying, if he needs to upgrade the version of their software, like a newer driver, a newer OS version, or to really replace the hardware because he will find X times performance improvement. So it's very interesting to understand that MLPerf can provide this information.
Yeah, yes, exactly. So, like you said, it's a very good way to measure systems. Now, is this the perfect way? Well, there's no such thing as perfection, right? But this is good. This is actually good in terms of what customers are able to leverage from. And this was not quite before MLPerf. What did we have? We had these siloed benchmarks, and these siloed benchmarks were, if you were to run those benchmarks, they were good. The models were good and everything, but there was not a fair way to measure systems across. You had different hardware vendors doing their own thing on their own software stack. You had different software vendors doing their own stack. And then you have OEMs trying to work with all of them and trying to give different numbers. So these numbers are what could be considered relative. Somebody says this is the best result for them. Somebody says this is their best result. What do we take? You can't take everything out of face value. The other challenge with the siloed benchmarks were, some of them measure throughput. And as you know, throughput could be manipulated. You increase the batch size, you're able to get better throughput. But MLPerf specifically measures the time to convergence. So you can improve the batch size, but you cannot easily cheat. Maybe I don't like that word, cheat, but you cannot manipulate the time to convergence by improving the batch size. So that's a big win for MLPerf, because now it's actually trying to match the time to convergence using that as a metric. And this is what allows customers to be able to be fairly confident that this is not just about improving the throughput, this is also improving the entirety of the training process. And that was a big win that MLPerf got, in addition to making apples to apples comparison possible.
And that's a huge win, especially considering, going back to Fabricio's point and your point about how credible it is, and how Fabricio mentioned, you can get access to things like power consumption, because we're seeing a lot of new regulations, from different governments, especially in Europe, for example, about how much power can be consumed by the different servers. So we're also, helping ensure that we're building sustainable data centers. And when you're doing that, you can't build a data center and try to make sure it meets a certain requirement with data that may be manipulated or may not be credible. So it's really good that you mentioned, those aspects that ensure that it is that everything's fair and that the results are actually accurate. And any more questions, Fabricio?
I also want to mention the results are having to go through a peer review process. So there is a submission committee that reviews the result, and this is a closed review process. And this review is thorough because it checks for a lot of the discrepancies in the submission process. It checks for the mechanized way, is somebody actually making fair submissions, or are they manipulating the results? So there's an automated way, and then there is a manual way where all the submitters can. It's a very interesting process where submitters are allowed to challenge the other results. So this provides more transparency and provides more, better ways to make the results even better. So this submission is not just make a submission and it's over. There is a review process. And once the review process is over, then MLCommons certifies all the results, and then they are official and valid. Others can actually run MLCommons submissions without making it to the review process. Those results are unverified. And maybe there is truth to those results, maybe not so much, because it's not thoroughly stamped. It does not have the stamp of approval of MLCommons. And it is important to make submissions that have the stamp of approval of MLCommons.
I have one last question, Nomuka, if you allow me.
Yes.
As Rakshith mentioned about the time for conversions as one of the main results or target of the training benchmark, I would get in this subject of the results. So what are the key highlights of the last MLPerf submission of training that our results, and what are the performance gains that were observed on, and how they will impact our customers?
Yeah, that's a great question. Thank you for asking. So, like I said, we have made submissions for several different rounds. And each round, there's always something interesting that we find out. Some of the interesting points could be, well, we made a new hardware submission and new system submission, which is great. Now you can see improved performance. You can see that we made a new software improved performance submission. That is also great. But this round, we had another interesting submission, which was the Stable Diffusion. So Stable Diffusion benchmark aims, as you may know, is a generative AI benchmark that takes a text and produces an image. And it's actually very prevalent, and almost everybody knows what Stable Diffusion is. So MLCommons introduced Stable Diffusion as well. And this benchmark was a way to allow users who are interested in generative AI to be able to make comparisons. So our result, which is very unique, because we are the only OEMs who made the Stable Diffusion submission. And the other submitters who made the submissions were NVIDIA and Intel Habana Labs. So it's very unique in the sense that it is exclusive by us for the OEM compared submissions. And the results were very good. So we were able to achieve convergence in about 46 minutes. And although it's not the entirety of the data set, you can look into the depths of what Stable Diffusion training is doing. However, the results for our submissions are doing really good. For example, we've continuously secured a lot of #1 titles. So the Stable Diffusion submission was something that's unique. We've secured a lot of #1 titles with our 4 GPU system, the XC8640, and our liquid assisted cooling system, the XC9640, and that also has the 4 GPU HGX baseboard. So we've actually accumulated and obtained several #1 results. These results are great. It's a testament to show that Dell is committed to advancing the AI system performance, and by that, the customers are also able to derive such benefits, whether through new hardware installation, acquisition, or through just the software improvements. The challenge with new systems could be that, hey, what happens if I update my system with the software support? Would I have a lot of headache with my IT process? Would my job be stalled because the software isn't supporting? So a lot of the questions are there that, by making submissions like this could be clarified. So when somebody makes a submission, somebody like us makes a submission, the questions such as, would H100 GPUs have a lot of bugs? Yeah, I mean, we are able to make submissions that are very good. And the results can be classified as, well, this is good. Maybe there could be small amounts of bugs here and there, but it's actually able to get a lot of the stuff done. And, stuff like that, in addition to being able to show that we have #1 results, would be useful to customers, that it actually works. It is able to get better results. It actually works. It is very scalable. For example, we made submissions last round, this round. We have made several submissions that have multi-node results. For example, last round with 3.0, we made a submission with 64 A100 GPUs. This round, we have made a submission with 16 H100 GPUs. So there is plenty of interesting avenues for customers to explore if they want to look at scaling results, or if they want to compare between the same systems. Oh, would liquid assisted cooling be better than the general air cooling? We've made submissions with such servers, and customers are able to leverage from that as well. So from a bigger picture, this is something that I'd like to emphasize is there's a lot of energy and effort that has been put into making these submissions. So our customers, partners, vendors all the other end users are able to derive the best that they could from making reasonable judgments about the numbers that these numbers are representative of, and they are comparable and all the good stuff that comes along with it.
Yes, and we
And
will definitely link all the information in the description. Sorry, Fabricio, continue.
no, I was just to agree and highlight one thing, that the Dell commitment to provide as much information as we can to our customers. So we are always in the front end to getting the newest systems, getting the newest benchmarks tested, and even sometimes getting an old machine running the newest benchmark, just to show the customer if they upgrade the system, if they go to the other, that's will be the difference. So as you mentioned, I know how much effort we put on the benchmarks to really publish this and cover the more number of systems and results for our customers.
Yeah, it is a combinatorial explosion problem with more GPUs, systems and CPUs. And so, yeah, thank you for recognizing that.
Yes.
So we have to do some trade-offs. We have to do some trade-offs, and those trade-offs are very intentional. Some of the trade-offs could be, how do we showcase that the same system customers can actually use? Some of the trade-offs include, would it be easy for customers to just do a software upgrade? When we make those submission decisions that we do, those trade-offs revolving around the customer's interests and what is of their what piques their interest, so or what is needed for them at that time and hour. For example, there is interest because of the H100 lack of availability. Customers want to have access to L40 GPUs. So what would that mean for customers? So we are, some of the benchmarks that we've submitted, sometimes we would go as far as to run an unofficial submission and provide numbers to the customers so they're able to compare hardware when such hardware is having a lot of logistical challenges, such as availability and things of that nature. So the trade-offs has been intentional, and there is certainly an avenue for us to keep filling the entirety of the matrix, but it is a challenging effort. There's considerable amount of effort that goes into making this. So thank you.
Yes, to help customers adapt to those changes. I really like that. There's a lot of effort on that front. And as you guys were talking, it almost seems like customers can simulate what would happen if they did something, and they don't have to be the guinea pigs themselves. They can see,
Absolutely.
in this case, what would happen.
Yeah, in closing, I'll tell you this. If you are interested as a customer to be able to experience the compute that, okay, how will H100 perform for my workloads? Okay, we like that you have these MLPerf numbers. So how can I best use this? There is an avenue that customers can actually request access to our HPC and AI Innovation Lab. So they are able to remote into our systems. Of course, you need to go, contact your Dell representative, a local Dell representatives to get you started. But once you're in, you're able to access, compute that, you can bring your workload into the servers and test it for your for your content. So the results are one way to showcase that Dell servers are excellent. The results actually showcase that we want to give large spectrum of results and also be able to help customers in advancing their journey. But also the firsthand experience of running workloads on their own is another avenue to help customers for their benefits for their use cases. The other thing is we also work with customers on their POCs. So these are some things that you can actually talk with the Dell representative, and they should be able to guide you. But in general, MLCommons results are becoming the de facto benchmark for MLPerf, and is a quintessential for what could be comparable across different systems. System meaning hardware, software, and that make a lot of the needs for customers to be able to get their job done, AI workloads, to their maximum benefit.
And save a lot of time. And yeah, thank you guys so much for being here. Any final thoughts, or exciting news coming from Dell?
Yeah, thank you. I've been talking a lot, as you can see.
I love it. A lot of good information.
The one final thought would be that MLPerf makes benchmark submissions available every 6 months, and we hope to make submissions for the upcoming benchmarks. It's an ongoing cadence, and when we do that, we also write blogs, so customers are able to access those blogs as well. Perhaps we can link some blogs.
For sure.
But usually, whenever there is a new benchmark result that comes out, we also release with a summary blog. And the summary blog just kind of guides the customer on what to expect. So expect that we release published blogs for whether it's training or inference. And hopefully those blogs serve their appetite to learn more about these results. So that's all I have. Thank you.
As a reader of those blogs, they're much needed. So thank you so much for that. And any last words for Fabricio?
Just say thank you to Rakshith, thank you to Nomuka, and remember that we should have the next inference one benchmarks submitted on beginning or mid of February. So very soon we will have more things or more results to share with our customers.
Absolutely.
Awesome. I'm looking forward to that for sure. Thank you so much again for being here, and thank you for watching, and stay tuned for more tech talk as we look forward to more technologies coming from Dell in the world of AI and ML. Thank you. Bye.
Thank you. Bye-bye.
Thank you. Bye-bye.